Hi, this is Ms. McCahan, and we're going to talk about the midsegment theorem in this video. Please write on your guided notes and take notes on that sheet of paper, and please feel free to pause this video as we go through. So let's talk about what a midsegment of a triangle is. So all that really is simply a segment that connects the midpoints of two sides of a triangle. So let's look at the theorem and what it says. The midsegment theorem says that this segment that connects the midpoints, the midsegment, and in this diagram, DE is our midsegment. What it tells us is that it's going to be parallel to that third side, so you notice that this segment DE is parallel to AC, and it is also going to be half as long as that third side, so DE is only half the size of the side AC. Now I wanted to talk about this a little bit more and see why that even makes sense. So we're going to use what we know about similar triangles to help us with this. So let's take this figure again, but let's say all we know is that we have DE and it is a midsegment of this triangle. So we just have this segment and it connects. See, we have this mark, this is the midpoint, and this is the midpoint of this side. Okay, so if we try to look at these as two separate triangles. So let's look at this as the top triangle and then this larger triangle. So we've got triangle DBE at the top, and then we've got triangle ABC at the bottom. Okay, well, let's pick some arbitrary side lengths so that we can figure out what's going on here. So there's nothing special about these lengths that I'm picking. Let's just say that these are each worth 6. So if this is 6, this has to be also 6. And let's just say this is 7. That means that this length is also 7. So when I split these triangles up, this side also has to be 6, and this side also has to be 7. Now for the big triangle, think about what that's going to be. On ABC, this whole side is going to be a total of 12, 6 plus 6. And then this whole side is going to be a total of 14. So we've got these two triangles. And also notice that we have the same angle at the very top, right? We have angle B, and that's the exact same angle as this angle B. So those angles are congruent to one another. So this kind of looks like side angle side of similarity. But first we have to check to see if those sides are proportional. So if I put this side 6 over its corresponding side 12, and if I put this side 7 over 14, and I reduce both of those, I get 1/2 for each of those. So each of those reduces to 1/2, so I know that these two triangles are proportional since their sides are proportional. So I can say triangle DBE is similar to triangle ABC by SAS similarity theorem. So what does that mean for us? Well, first of all, we know that all the angles have to be congruent in similar triangles. So I know angle E is congruent to angle C. And if I go back to this diagram, that means that this angle right here is congruent to this angle right here. So how does that help me with the midsegment theorem? Well, these are corresponding angles. So that means that this side is parallel to this side. So that's how they're getting the parallel part. Now let's talk about how we know this side is half of this length. Well, if we go back to the scale factor of these two triangles, this side was exactly 1/2 of this side, and this side was exactly 1/2 of this side. So this third side right here, whatever this is, let's say that this is, oh, I don't know, 8, then what would this side have to be? Yeah, exactly, it would have to be 16. So I know that whatever this side happens to be, and again, I just made that up. There's nothing that says that that's 8. But if whatever that side is, it has to be half of whatever this side is. Or this bigger side has to be double of what this side is. All because these are midpoints, and this is always going to be half, no matter what triangle it is. So that's our midsegment theorem. Let's do a few examples so we can see how this works. So in our directions, they tell us DE is the midsegment. So it might help you to mark sides congruent so we know that D is the midpoint of that side and E is the midpoint of the other side. So what our theorem said was that this mid-segment has to be half as big as this bigger side. So if I know that 7 is half as big as x, then x has to be twice as big. So x has to be 14. Over here, since we know that E is a midpoint, then I know that segment AE is congruent to EC. So these two have to be the same length, which means that X has to be 8. They have to be the same length. And then going back over here, we're kind of going backwards from number 1. Now here we know the big side, the largest side, so X has to be half as big. So, or in other words, I have to have 2 of those X's to come up with the 34. So if I do that, I would have x plus x equals 34, or 2x equals 34, and then x equals 17. So however you want to think of that, if you want to think of that as taking half of 34, or 2 times what equals 34, that's how we get that value of x. Now these are pretty basic. We're going to move on to some harder problems that involve more algebra. So let's look at this diagram. We have triangle GHJ, and D, E, and F are midpoints of the sides. So I'm going to go ahead and mark those so I know what's congruent to each other. And you do the same on your diagram. So they also tell me that the mid-segment DE is equal to 4x plus 5. So I'm going to label that in my diagram, and you do the same too. So I'm going to put that. That's 4x plus 5. And then GJ is 3x plus 25. So again, I'm going to label that. Now remember, GJ is this whole length here, all the way from G to J. Okay, so that's the whole big side. So what we can do now is we can say, all right, I need 2 of those 4x plus 5s to equal that big side. So if I create that equation, then all I have to do is solve for that. So we're just going to distribute. So I'm going to get 8x plus 10 equals 3x plus 25. Then I'm going to subtract the 3x from both sides. That gives me 5x plus 10 equals 25. And then I'm going to, subtract that 10 from the 25. That gives me 5x equals 15. And then divide by that 5. So I'm going to get x equals 3. Now remember, I'm not just trying to find for x. In the directions it says, what is DE? So they want me to find the whole length of DE. And we know that DE is equal to 4x plus 5. So all I'm going to do is plug in the x. So I'm going to plug in 4 times 3 plus 5. And we know 4 times 3 is 12. So DE is the length of 17. Now another way you could have thought of this is by saying 4x plus 5 is equal to 1/2 of 3x plus 25. So if you'd rather think of it as a half rather than doubling this, then you can do that as well. You just have to deal with fractions or decimals. So I chose to distribute and use decimals. So if you do that, I'm going to get 4x plus 5 is equal to 1.5x. So I did the 1/2 times the 3, that's 1.5. And then 1/2 times the 25 is 12.5. But then you just solve like normal. So I'm going to subtract the 1.5x. That's going to give me 2.5x plus 5, and that equals 12.5. Then I'm going to subtract the 5. That's going to give me 2.5x equals 7.5. Then we're going to divide by the 2.5, and that gives me x equals 3. So I get the same thing as when I did over here, and then we're going to do the same thing by plugging in the 3. So either way you like to do it is up to you. I know a lot of students in the past have liked to do it this way since they don't have to deal with a fraction. But whatever makes sense, you use. Let's do some more. So let's look at these. Both of these multiple choice problems have to deal with this diagram. So in this diagram, we have U, V, and WU are mid-segments. So I'm going to mark those. So UV is a mid-segment. That means that U is a midpoint, and then V is also a midpoint. And then it also says that WU is a midsegment. So we already said that U is a midpoint, but we need to also say that W is a midpoint. So we're going to mark that so we know that W is a midpoint. Now, we are trying to find this segment WX right here. Okay, so we would need to know how big that is. So notice that this is part of this larger side over here, XY. So I'm going to highlight this for us so that we can see what's going on here, because there's two different midsegments going on. We're going to focus on the midsegment that's parallel to this one, that's UV. Okay, so if I have UV is 5, then we know that this whole side has to be twice as big. So I know this whole side, XY, has to be 10. Now, if that whole side is 10, and we know these are both equivalent to each other, then these each have to be 5. So again, you can see that this bigger side has to take 2 of these in order to equal the whole side. So our answer over here is A, which is 5. Now, on number 2, they're asking us to do a different part. So I'm going to get rid of this red piece. Okay. We're trying to focus on WU. We need to find how big is W. So I'm going to highlight that. So I want to know how big that is. Now notice that's actually a midsegment, and that's parallel to this side over here. So just so you can see which part of the triangle we're dealing with, I'm going to put this blue thing over. So I'm dealing with this side and this midsegment. So we already know this whole long side is 8, and this midsegment has to be half of that. So I know that WU has to be half of 8, which is just 4. So I'm going to have my answer D, which is 4. Now we have one more multiple choice problem. And in this one, we are asked to find the perimeter of triangle KLM. So remember, perimeter means that we have to add up all of the sides of this triangle. So I have to find this whole length, this whole length, and this whole length. And they only give us that this was 15 and this was 25. Now, they also gave us that all of these are midpoints. O, P, and B are all midpoints. So they have those marked. So because this is 15, then I know that this will also be 15 right here, K to B. So because of that, I'm going to label this whole side right here, KM is 30, because I'm just going to do 15 plus 15 is 30. All right, so let's see if we can find another side. Now they tell me that this midsegment right here that they drew in from B to P, that is 25. So because that's 25, I can figure out that that side it's parallel to, KL, is going to be twice as big. So KL has to be 50. Now the problem is we don't know this third side. They didn't tell us what that other midsegment was right here. They didn't tell us BO. So we can't use that to help us find this side. So the only other thing we can do is look at this. This might have been hard to see, or you might have not have seen that, but this is a right triangle. So because it's a right triangle, we can use the fact that we know a squared plus b squared equals c squared. So we already know this is 30, this is 50. So we're going to try to find this side over here by using the Pythagorean theorem. So let's plug it in. I know that one of my sides is 30, so I'm going to put that in for A. I don't know this side, that's my B, and then remember C is always that longest side across from the right angle, so that's 50. So we have 30 squared plus B squared equals 50 squared. We're going to square those numbers. 900 plus B squared equals 2500. Then we're going to subtract 900, so we get B squared equals 1600, and then square root. So we got B is equal to 40. So I know this side over here has to be 40. So this side's 40, this side's 30, this side's 50. So for my perimeter, all I have to do is add up the 50 plus I don't want that. The 50 plus 40 plus 30. So if we do that, you can either do that on your calculator or in your head, we should get 120. So that would be answer choice B. All right, so we're going to be talking more about midsegments and special parts of triangles later on. And make sure to have all your notes filled out for class.